Hello YouTube. Watch this. Oh. Ah! Ow! What's up? I am back with a big video. Today you will learn how, from nothing, code a basic ESP for Counter-Strike 2. This ESP will show entities through walls, both teammates and enemies, with boxes and lines. You can also change the drawing color easily with our beautiful ImGui menu. I have a lot of ESP videos on the topic, but none of them are optimized like this tutorial. Previous projects lagged more, crashed more, and some didn't even use dumped offsets. But we fixed this in this tutorial. Subscribe, like, or write a comment. I would love to hear the next feature you want me to cover. You can also find the Discord server in the description. But remember, comply with the terms of service for the game you're coding hacks on. Many games permit it, and it's essential to respect their guidelines. All Swedz C# tutorials are designed with multiplayer disabled, and this tutorial will precisely demonstrate how to achieve that. Now enjoy this tutorial. Hello people of the internet, welcome to today's showcase. Let me just mute the audio real quick. There we go. Let's take a look at source code. So here is the project that we will create. In the end, we can see that we will draw boxes and lines to the different entities. It's not a lot of code. We will go through it step by step, and you shouldn't have a problem to follow this. But let's take a look at it in game as well. So before we run any application that manipulates the game's memory, we will go into Steam. Under the game Counter-Strike 2, we will right click on the properties. We will add the launch option -insecure. This is because without this you can risk getting banned. -insecure will disable VAC, and we can play on our own without harming anyone else's experience. So we can't join the normal matchmaking, but we can sit in a practice game all to ourselves and test our applications. So incredibly important, you can get banned otherwise. Inside the main menu, you can check that this is enabled by going into matchmaking, checking a map, and this window will come up saying that you have launched the game in -insecure. Otherwise, do not run any applications that could get you banned. Here you can now instead go into practice and play with bots like this. Alright, so let's try out our simple but beautiful ESP. So here I have CS2 in a practice game on Vertigo. We changed the map from our Dust 2. If we run it, we can see now that we have a little menu, and if we look at the teammates, they are the color green with both lines but also boxes. We can change the team color to whatever we want. Can pick white, can pick green, can pick blue, purple, something. Let's change the enemies. So if we look down there, we can see some enemies. Let's let them have a cool orange color. So, and you should notice now that the ESP is much less laggy. It's much more responsive. It's not perfect. You can see lag still, but it's 10 times better than before. So if we shoot enemies, you can see that they disappear from the ESP. If we disable the ESP, the boxes also disappear. That's our teammates. And I hope you enjoyed this tutorial. So, like always, we will create a new C# console project with the .NET version 8. Then we will set the build architecture to 64-bit. This is because CS2 is 64-bit. Then we will go into the NuGet packager to get the memory library Swedz64, because again CS2 is 64-bit. After that we will get the clickable transparent overlay. We will use the version 9.1 because I had some issues with the versions above. Now, before we can move into the logic part of the ESP, we will have to create a new class for the entity and rendering and so on. So we start by the entity class. This class will be public and it will hold the different attributes we will use. So the position, vector 3, view offset, also vector 3, position 2D, a vector 2, and view position 2D. So it's just 3D positions, then 2D ones. And at last we will have the team number, so we can differentiate between enemies and teammates. Then we will create the next class, which is the renderer. This will handle all of the drawing. So we will have some variables. The first one will be the screen size. So you will put your own screen size here. Mine is 1920 by 1080. After that we have some entities. We will create copies of the entities that we have from the logic side. So we will have a concurrent queue of entities, then one entity, local player, and then an entity lock object. We will go in more on these later, but they are for Fred's safety reasons. After that, we will inherit the overlay onto our renderer class. So we add overlay, we will have to be using clickable overlay and ImGui. Then we create the protected override void of the render method. Here is the rendering part, so where you can actually draw stuff on the screen. We will quickly create some variables for the GUI elements. So we will have a boolean enable ESP, that's the checkbox to enable or disable the ESP. Then a vector 4, which will be the enemy color. So because it's a vector 4, the values represent different RGB elements. So the first one would be red, next one green, next one blue, and finally the alpha. So with a 1 in the beginning and 1 at the end, that would mean red. 1 in the middle and at the end it would mean green. Alright, let's move on to the render method. Here we will create a new window, basic ESP, and with a checkbox, enable ESP, we will refer to our boolean up above, so it will be enabled by default, but once we change it, it will change the variable it referred to. Okay, so let's create the color wheels or color pickers for the different box colors and so on. So we will start with our team. It will have a collapsing header in an if statement, and if it's selected, we will show the color picker. We will refer to our variable just like before. After that, we will actually draw the overlay. So I will copy and paste this void of the draw overlay. It's just like before, but with the screen size as an argument, not longer a variable. You can copy this, or you can get it by following the Buy Me a Coffee link. I will make a post there where you can find the code. Alright, so I have created this getLocalPlayer method to safely access the local player, but I just noticed that we actually don't use this method at all in our program, so you don't really need to write this at all if you don't want to, but if you want to be my guest, you can write it down. But however, this other function will be used, so write this one down. Update local player. This will take an entity, a new entity, and lock our entity lock. This will prevent concurrent access. Then we will set the renderer's local player to the new entity. And after the update of the local player, you probably guessed it, we will update the entities list. So we will have a function void update entities with IEnumerable with the entity class and then new entities. So we take in new entities and we will set the renderer's entities to a new concurrent queue of the entity class with the new entities. So different from before, we actually wait until the thread and the methods and so on are ready to update the entities. If you remember from earlier tutorials, we did not use this method of replacing the entities and so on, which led to crashes. And that's why we got flickering, that's why we got the lag and so on. So hopefully this will fix things. Let's add the drawing methods at last. So we will add the drawLine function. We will get the line color by comparing our local player.team with the current entity.team. If, and we use a question mark here, if it is the team, we will return the team color, otherwise the enemy color. So a shorthand line here. Then when we have the color, we will add the line to our draw list. So we will add a new vector 2 with the x as the screen size.x divided by 2 to get the middle part, and then the screen size.y as the y-axis. The second position will be the entity.position2d because that's where he is. Finally, we will use the ImGui.colorConvertFloat to U32 with our line color. This is because it wants a uint and we have a vector 4. Okay, let's get the drawBox method as well. It will have the same structure, a function with the current entity as the argument. Then we will have a float, which is the entity height. We will calculate it by subtracting the entity.position viewOffset minus our position 2d. It's actually wrong here, I correct it later, but it should be the viewOffset minus the position 2d. Then once we have the height of this box, we can create the dimensions of it as well. So we will create a rectangle. The top left part will be the view position 2d.x minus the entity height divided by 3 to create this width. Then the y value will be the entity.viewPosition2d.y. Then we will create the bottom of the rectangle. It will also be a vector 2 with the x position as the entity.position2d.x plus the entity height divided by 3 because it's on the right side. Then the y position will be the entity.position2d.y because it's the ground. So what we have done is we have subtracted the height divided by 3 on the left and added the height divided by 3 on the right to create this width of the box. So once we have the dimensions of the box, we will add a box color just like before, and then add the rect top, the rect bottom, and the float to U32 box color to the draw list. Let's go back to the render method where we left off. We will add draw overlay with the screen size as the argument to draw the overlay. Then we will give the draw list variable the value of ImGui.getWindowDrawList. After that, we will actually begin the drawing loop. So if our ESP is enabled, we will loop through all of the entities for each entity in entities, and we will check that they're on screen really quick. So we create another function, a boolean entity on screen, which takes an entity as the argument, and we will check the x axis of the entity to the position, and if it's greater than 0 or the bound of the screen. We will also check the y-axis if it's greater than 0 and within the bounds of the screen. If all of those factors are correct, we will return true, which would mean the entity is on screen and we want to render them. So we head back into the loop, check if the entity is on screen, then if it is, we will draw boxes and lines. That's it. We're done now with the rendering part of the program. We will now have to actually populate these entities variable to draw this stuff. But you can see the structure here. This rendering stuff is on its own. It just needs the data now. So we will go back to our program.cs and actually create some logic and get those entities. We will add using and then the namespace of the program. So mine is basic ESP tutorial. Yours will be different than using Swedz and using system.numerics. Like we always do, we will initialize our memory library Swedz with the CS2 process, then get the client module of the game. This is because all of our offsets are relative to the client module. We will also have to initialize the render class, so we create a new instance of the render and a thread for it. So we will have a render thread, which will have the argument new thread start, then the renderer.start.wait. So it's just like before, but we're using a new thread. Then we start a thread. Then we will get the screen size, because we will perform calculations here and we need that screen size. Get it from the renderer. We will also store our entities. So these ones we will populate first, then copy over to the renderer side. Now we need some offsets, so we will head into the A2X damper on GitHub. Credit goes to him for this beautiful offset damper where we can get updated offsets for CS2. We will go into the generated folder and the offsets.cs file. Here we will get the DV entity list, the DV view matrix, and the DV local player. Then we move on to the client.dll.cs file, also in the generated folder. Here we get the v old origin offset, the team num offset, the live state offset, the h player pawn offset, the vec view offset. Now let's create the ESP loop. So we will have a while true to have it always run, and we will start by cleaning the entities list. After that, we get the entity list address by using swed.readPointer with the client and the DV entity list offset. Then we will make our first entry a list entry, also using swed.readPointer, but now with the entity list address and the offset 0x10 or 16 in decimal. After that, we will get the local player pawn's address by using the swed.readPointer with the client and then the DV local player pawn offset. Once we have the address of the local player pawn, we can get our player's team. So we will use swed.readyInt local player pawn and team num. Alright, so after we have gotten the local player team, we will loop through 64 potential controllers. So we get the current controller by using swed.readPointer with the list entry now and the current iteration I multiplied by 0x78. So 78 is the step. We check if it's valid, not a int pointer.0, and if it's valid, we check the handle. So we read the pawn handle with the current controller and the H player pawn offset. If that is not 0, we will get the current pawn by making a second entry into the entity list, but with our pawn handle as the ID. If you want more detailed information on this, then I suggest you watch my entity list video on this. I explained the bit mask and stuff there. And we read the current pawn with our second list entry now, list entry 2, and the step 78 multiplied by now the pawn handle as we're using it as our ID. We also check if it's valid. Before we populate our entity with information, we will have to check that the entity is alive. So we read the live state with the current pawn and the live state offset. If it is equal to 256, it means it's eliminated. Then we skip this iteration. Because we want our ESP function or feature, we will have to bring these 3D values into our 2D points on the screen. So we will have to create a world to screen function. We will create a new class for that, a static public calculate class that will have the static method vector to world to screen. So we bring the world onto our screen. If you have watched a lot of tutorials on this channel, this should be pretty similar to you. But if you're new here, we will take 16 floats from the game that is located at our camera, which are values we will use to convert these 3D ones to 2D ones. We will take the matrix, the vector free position, and the window size, so we calculate this onto our screen. The first variable will be the screen W, or the depth variable. We will calculate the screen W by taking the last row in the matrix, or the last vector, multiplying it by the 3D position or the vector free positions, and finally adding the last translation value. So the matrix has 4 values and we have a 3D position. So this view matrix, it has 16 floats, so it's a 4x4 matrix. The first row is 4 floats and so on. The last row would start from 12 and end at 15 because the index starts at 0 and so on. Now, because we have an idea of the depth, we will check that the screen W is greater than 0, which would mean the entity is in front of us. If that's the case, we will calculate the screen X and Y. So to calculate the screen X, we will take the first row of the view matrix and multiply it by, again, the vector free position. So we multiply it by the axis and add the last value in the matrix as translation. For screen Y, we do exactly the same as before. It's a repetition at this point, but we use the second row instead, so it starts at matrix with the index 4, and we add the last one in the row as translation. Alright, so we have the screen X and screen Y values, but we need to calibrate them with our screen W to get the correct depth. So we perform perspective division by taking the window size.x divided by 2, so the half of the window length, plus window size.x divided by 2 multiplied by the screen X divided by screen W. So we start from the middle and sort of get the depth like you would draw a picture in arts class, if you ever did that. I did. And for the Y calculation, we just take, you guessed it, window size.y divided by 2 to get the middle. But now instead of adding, we will do minus window size.y divided by 2 multiplied by the screen Y divided by the screen W. we can finally return the new x and y positions in our vector 2, or if it or the entity was behind us, we will return a value that's out of bounds, so -99 and -99. We will head back to our program.cs and read the view matrix, so it's a float matrix like we saw before, but we will use Swedz.read matrix with our client plus the dv view matrix. Now that we have the view matrix values, we can create a new entity and populate its data. We will set the team as the Swedz.read int with the current pawn and the team num, just like we did the local player. The position with Swedz.read vector or vec with the current pawn and old origin. View offset the same, but with the vec view offset. Now, what's different is the position 2D. We will now use the calculations because we have the 3D value and we want the 2D one. So we will use the view matrix, the 16 floats, our entity's position, and finally the screen size. Our view position 2D, the next part, will be the same, but with our entity position and view offset added together. So we will use vector3.add. I made a typo here. So the view offset has only one value in its C position, and it's the length between our position and the camera, or whatever you would want to call it on the player. So we can add that to get sort of the height of the character, and that's what we want because our box should have a height. At the end, we will add our entity to the entities list, and after the whole loop, we will update the renderer's entity copies, but we will use our thread safe functions instead. So we use update local player with the local player and the update entities. We pass in our entity variables here, local player and entities. You can also add at the end a thread.sleep if you want to, but it's not really necessary. Let's try out our ESP in game. After all of this work, you should be proud over yourself if you have made it this far. Alright, so before we actually start it, quick bug fix on the drawBox method. We need to use the entity.viewPosition2D. Very important. So, before we run any application that manipulates the game's memory, we will go into Steam. Under the game Counter-Strike 2, we will right click on the properties. We will add the launch option -insecure. This is because without this, you can risk getting banned. -insecure will disable VAC, and we can play on our own without harming anyone else's experience. So we can't join the normal matchmaking, but we can sit in a practice game all to ourselves and test our applications. So, incredibly important, you can get banned otherwise. And if we run the project, if all the offsets and code are correct, we should now see boxes on top of teammates. You should see now that it's much more responsive than before. It's still a bit laggy, but it's barely noticeable if you ask me. We have team colors. We can change them to whatever we want. Look at that. Purple. But if we look at where the enemies are, we can see that they have the box color red. We can disable the colors. We can change the enemy color to something cool. Let's pick the orange one. Yeah, that looks very cool. Let's take a look at the entities up close. Would you look at that? So, it's an ESP. You can see the entity boxes. they disappear once the enemy is eliminated. Can change the colors, we have lines. That's pretty much it. So